Vero plebem dolentem, que subito patrem perdiderit, adquad arma capienda paratissima.
Hi, so tutapea watu a few minutes. Tukifika a good number we will start. So I hope hawatakawia sana. Hi guys, thanks for joining. Tunangoja a few more people and then we'll be able to start. So if you can give them like 2 or 3 minutes and then we start. Ama tukifika a good number we'll be able to start. So msi left. Also, while we wait for other people, can someone unmute? Are you able to unmute yourselves and say something so that nijue if you guys can also participate in the conversation? If you guys can unmute, mtu aniambie. Hello, mnanisikia? Am I audible? Ningetaka kujua kama mnaweza unmute yourselves so that in case you have a question you can ask. But can you guys unmute yourself? Can you speak? Okay, we'll start in 2 minutes. Let's try to try to refresh your browser ama you leave and then you try joining again. I've changed some settings so that internet is unmute. So you can leave and then rejoin and then tell me if you can unmute yourself now. Hi guys, I am so sorry. I didn't know that sikuwa unmute. Let me just go back really quickly and uh, and start about really quickly. Thank you, John Mark. Sikuwa realize that sikuwa unmute. So I was saying that my name is Alvin Kamau. I am a student at KCA. I study information security and forensics, and I'm also the AI lead at KCA. So I'm the one who will be leading us in these sessions that we are going to be doing. So that is me. And the vision statement, this is what I personally believe, and I hope that the AI chapter of the KCA club will be able to foster and to grow and to be like. So it is to be the leading hub for AI education, innovation, and ethical application at KCA, such that other universities can come to KCA to experience AI and to learn from AI, such that KCA will be the hub for AI, and to foster a community of AI enthusiasts who will shape the future of technology. Just like we were discussing kwa group the other day, that we shouldn't be left behind as Kenyans or as Africans. We should also participate in this AI move. This is what I hope, and this is what led me to start the AI chapter of KCA Tech Club. This AI chapter of KCA Tech Club didn't exist before last semester. I'm the one who came about, and then I decided to start it because I was like, why are we not participating in this AI thing that is happening all over the world? So yeah, the mission statement is to advance AI research and education at KCA. And I was saying here that I had invited one of my lecturers who teaches me machine learning. I don't know if she'll be able to make it, but I had invited her to come and join. And for us to be able to advance AI research and education, we need to involve people who are already in the marketplace, and people who have been in this sector for longer than us, so that they'll be able to teach us things we don't know and to help us do this research and building of new technologies. So the mission statement is to advance AI research and education at KCAU, fostering innovation that addresses real-world challenges and ensures the benefits of AI are accessible to all. So this is to be able to build solutions that address real world challenges that we ourselves experience as KCA students, or just Africans and Kenyans in general, so that the benefits are not just, we are not just seeing people are participating in this AI thing abroad, but we ourselves are not benefiting in any sort of way. So that's the mission statement. And then what is AI? I'd like us to start here because if we miss the definition of artificial intelligence, all the other terms that are usually used in place of AI might confuse us. So first of all, AI is a field of computer science that is concerned with the building of computers and machines that can reason. Reasoning is like thinking. So somebody asks you a question and then you reflect on it, you think about it, you do something like that so that you're able to come up with a response. That's reasoning. And then learning is your ability to get process information, and then that information is saved up in your memory as new knowledge. So that's learning. And then acting is now after you've gone through the process of reasoning and learning, you are able to act in a certain way that would normally require human intelligence, or that would surpass what humans are capable of. So that is what artificial intelligence. And I was saying before while I was muted that things like ChatGPT have amassed so much knowledge that no one human can be able to do that. You can ask ChatGPT a question like who in areas like computers, you can ask it about any science, medical, any physics question, any cosmology question. You can ask it any question and it will be able to have a response to it. No one human can be able to amass all the knowledge that a large language model like the one being used by ChatGPT has been able to amass. So that's what AI is. That's the definition of AI. And in AI, there are different subsets of AI or that bring about artificial intelligence. The main one is called machine learning. Machine learning is what gives machines the ability to mimic human intelligence, gives machines the ability to learn from certain sets of data and to produce intelligence that would look like it is that of a human. So that's what machine learning is. And under machine learning is we find deep learning. And deep learning is a subset of machine learning that where we find algorithms that now bring about generative AI. And we're going to learn more about this. So there's discriminative AI and generative AI. The one that we'll focus on is called generative AI, and that is the one that brings about chatbots like ChatGPT, Claude, and Gemini. So this is how machine learning works, or this is just a high level overview. So you first of all have a large training data, and then you pass that data into a model, and then that model learns by trial and error. So you give it a question, like for example, this is a simple example. It's not necessarily what would happen, but you give a model a question like, "What is 1 plus 1?" And then it generates an answer like tells you 51, and then you tell it, "No, it is not." So then the model goes back and then it retrains itself, it corrects itself, and then it comes back to you and tells you 1 plus 1 is 3. And then you tell it, no, go back and try again. That's what the training happens. And then by the time it gets to 2, it is able to get answers to questions that are of a similar nature. So that's what the model training looks like. So once you get your trained model that has met your parameters, that has achieved what you want the model to do, you pass it new data. You give it new data. So you give it a different question, you give it new information, and then the trained model is able to predict a new outcome. So it's able to tell you this is what I think the outcome will be like. So for example, you have a list of uh, houses and their prices, and also how many rooms each house has. But you also want to add a new, so you train a model on that data of houses and how much each house costs, and also how many rooms each house has. You train a model on that, and once it is able to predict correctly, you pass it new data. So for example, you want to test to know what you should sell a new house that has come up in the market. So you pass it new data, you give it the house, you give it the how many rooms it has, things like that. And then once the model once the data is passed through the model, it is able to give you a prediction that is accurate according to the market. So that's what machine learning is, and that's how machine learning models are able to predict information. So there are two subsets of, there are two ways that machines can learn. One of the ways is supervised machine learning, the one is unsupervised. And in simple terms, supervised uses labeled data. So for example, you have I don't know if you guys have experienced this, but kwa your Gmail, you can go and check and see spam emails. For you to be able to see those spam emails, Google built a machine learning model that was able to predict, was able to detect spam email versus non-spam email, ama not spam email. So they needed to give a machine learning model a lot of data, but this data had to be labeled. So you give it an email and you label it, this is spam. And then you give it another email, tell it this is not spam. So once you do that over thousands and thousands and probably even millions of emails, it gets to learn the patterns within spam emails and the patterns within not spam emails, such that once you give it a new email, it is able to tell you this email, this is a spam email. Then it takes it to the spam folder for you. So that's what supervised machine learning is. You give it a data set, but the data set has to have labeled data like spam and not spam. Of like for the example that I've given here, a data set that has cats and dogs. So you have a large image data set that has cats and dogs images, and then you have to label each image cats and then the ones for dogs. But now for unsupervised is where you do not have any labels. So you have a list of customers and you want to be able to cluster your customers according to their behavior. So for example, you have a list of like 1,000 customers and you want to know which customers are the ones that I should focus on, like I should market to or things like that, because their behavior is one of spending a lot of money. So you create a machine learning model that looks at all your customers. It looks at those who come to your shop very frequently and those who also spend a lot of money for each shopping spree that they have. And then you've clustered once the machine learning model has clustered your customers according to the parameters that you have set, it is now able to quickly tell you this is a customer that you should market to because they are willing, they are highly likely to spend more for you. Uh, that's something that platforms like Amazon does. So the other example that I've given here is a data set with no labels, such as your gallery kwa simu. Your photos gallery, you've not labeled each photo. Ukichukua a picture of someone's face, you don't label it, this is a face. It is the model behind it is able to cluster different images according to their characteristics. It is able to tell you this is the face of an animal, this is the face of a human, this is the face, this is the image of a sunset, this is the image of a car, things like that. You've not labeled your images, your photos like that for gallery, but the model is able to cluster images that look the same. That's what I'm trying to say. So supervised uses labeled data and supervised uses unlabeled data. So in deep learning, now this is where we use something called neural networks. And neural networks are what you find in your brain. In your brain, the neural networks are the ones that help you reason, help you learn, help you move about and act. Those are the things that make up your brain. But now the ones for computers are called artificial neural networks, not because they are fake, but because they are modeled from the real ones that are found inside your brain. So the one in letter A, this one, is the one that is found in your brain. It has these parts. Can't remember what we did in biology. And then it has this part, and then it has this. So you can look at it like this. This part here is the inputs, and then this part here is the part that processes the information, and then here is the output. Just like you would touch a hot surface, then usikie unachomeka, and then you react, you remove your hand. So this is where you would sense the heat, and then it is passed through and processed, and then it reacts. So you react by removing your hand. Same thing by what happens in an artificial neural network. It receives inputs, and then inside these things called hidden layers, these hidden layers are just layers in which mathematical operations are done, and then an output is generated. They're just called hidden layers because no one necessarily knows what happens inside of them. So that's why they're called hidden. We'll get to learn more about that. So there's the input layer, then the hidden layer, and then the output layer. So if you're generating an artificial neural network for telling you if an image is of a cat or a dog, it will take the input image, and then inside here it will do the process that it is done, all the computation that it does, it will do it here, and then it will give you a probability. I think that 60% of this image, I am thinking it is that of a cat, and the other 40% I think it is that of a dog. So the higher probability is the one that is chosen to be the output ama the prediction of this model. So yeah, that's it. So there's discriminative models aside from the generative AI models that we are going to learn. So discriminative models, these are the ones that learn from the labels of the data and can classify between cat and dog. So we've already talked about a model like that one that is able to tell you whether this is spam or not spam. That effect of saying this thing that you've given me is either this or this, that is called discrimination. So that's why it's called discriminative models. But now we go to generative models. These are the ones that generate information. Out of the information you've given it, it generates more information. So you can have text to text, like the one you find on ChatGPT. You ask it a question, it responds in text form. There's also the one where you do text to image, you give it a text, give it a prompt, and then it generates an image for you. Same thing with text to video, text to 3D, text to task, like the ones I found on Google Assistant. So you tell it to set for you a reminder for something. So you say that in text or you say that in speech format, and then it sets the task for you. And then finally, there's image to video. So you can give it an image and then it generates a video out of it. So these are what are called generative AI models. So now I would like us to focus on how do LLMs work. Large language models, first of all, start by collecting lots and lots of data. Um, and these are gathered from books, articles, websites, and one of the data sets that are used is this one called Common Crawl. Let me click, let me show us. Share screen. We do this one. So this one is called Common Crawl, and they've been crawling the internet since 2007. So all the textual information that has been on the internet since 2007 is found in this data set called Common Crawl. It is free, it is open, and this is one of the data sets that was used by Akina ChatGPT when they were building by OpenAI when they were building ChatGPT. This is one of the data sets they used. Another that has been used recently is this one called FineWeb. And this one by FineWeb is a beta version of Common Crawl. It is better because they've once these models started being built, people tried to figure out ways of condensing all the textual data in the internet into a better way instead of the hard coded one or the brute force one that Common Crawl have done. They've not cleaned the data, they've not done anything. It is just what is on the internet, all the textual data. This fine web has been refined and put into such a way that it is very clean to be used by large language models. So this is the one that is used by the large language model that we use on a day-to-day basis. So yeah. So those are the data sets. You need a large data set that contains the information that you want to learn from. So in this case, we are learning from the textual information on the internet. Then, so all this textual data is is in character form, such that each text, like for example, this word tokenization, the word T occupies a certain amount of space on memory. So T occupies a certain space on memory, O the same, K the same, E the same, and like that, like that, like that. But these large language models have a limitation. So you see the way kwa ukiwa na an A4 page, there's a limited number of words you can write kwa an A4 page. You cannot write an infinite amount of words or an infinite amount of characters. Si kuna limit. Just the way kwa A4 page kuna limit ya the number of words you can write. That's the same thing with large language models. They have a limit as to how many tokens or words, before I even introduce the word tokens, how many words they can see ama they can process at one go. And this limitation has been set in place by compute power that we have. The compute resources of the earth are not able to compute all the world's textual information at one go. So each of these large language models that are used have something that is called a context window. A context window is just the number of words that it can process at one go. So now, uh, because there is a finite, a limited number of words that these models can see or that can process in one go, they do something called tokenization. And tokenization is the process of breaking down this large text that I have collected into something that are called tokens. So as you can see here, I have three sentences here that says, my name is Alvin Kamandirango. This is an egg. Eggs are tasty. You see, um, each of these words iko highlighted in some way. So like the word my is highlighted color blue. The other one, my name space name is highlighted color yellow. Then space is highlighted color purple. Space AL is highlighted color green. And then VIN is highlighted this color. So just imagine, out of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Out of having 32 characters in this one sentence, because we've tokenized this sentence, we now end up with how many tokens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. From 32 characters, individual characters, to 11 tokens. That means that if we pass this text in a large language model that has been tokenized properly, it will be able to see more things. Because if we were to just give it basic tokenization in character format, ingeona 32 characters, but if we tokenize the words, we get tokens that give the model the ability to see more. So inaona 11 once it is tokenized properly, and once kama ija tokeniziwa itaona 32 characters, which is occupying more space than we want. So tokenization is the ability to break down each word into certain tokens. And the best large language models are the ones that have a large vocabulary of tokens, such that it can break down the words into many tokens, but have into a lot of vocabulary. These sub tokens, these ones, it has many of these, but not in character format. Character format is not a good performance. But you can also notice here, this word egg, hapa kwa this word egg, space EGG is one token. But also this word eggs here is broken down into two tokens. That means that words that are in different kama ikiwa na capital na ikiwa na small, those are two different tokens, and that enables the large language model to learn even better because it knows when to use the small case words, when to use the uppercase words. I hope I've explained vizuri hii mambo ya tokenization. I'm trying to simplify it as much as possible so that nisiwa bore na nisiwa stress. So the next part of how LLMs work is called model architecture, and this is what enabled the large language models and things like ChatGPT to be able to work. And this model architecture is one that is called a transformer. It is not this type of transformer, but it is this one. You don't need necessarily to know what these sections of this transformer architecture do, but just know that this transformer architecture takes in tokens, individual tokens, and not the words. Remember, not the words, but tokens, and not also the characters, the individual characters, but it takes in tokens. So these tokens that tumeona hapa, like the word my name is, these tokens are the ones that are passed into this model, and then this transformer is the one that predicts the next token. These LLMs are just over glorified autocomplete. Just the way you can type kwa text, ukitext mtu umtextie something and then uone certain words zinakusuggestia that you can type the next word. That is just basically what the transformer architecture is doing. But the transformer architecture that is used for LLMs is a lot more powerful than the one that you use for autocomplete kwa simu. That's just it. Just know that this one is more complex and more powerful than the autocomplete that is kwa simu yako. So yeah. And now, how does this architecture learn information and learn knowledge? First of all, I need to define what training is. Training is when the model learns how to predict the next token. Just like when Mwambia that the LLMs are just over glorified autocompletes, is because they are just trained to predict the next token. And they do this by let me just show you how they do it. So for example, you're given an example like children enjoy going to the, so the LLM generates this possible continuations of this sentence. So children enjoy going to the, then there is cafe, there's hospital, there's playground, there's park, and there's school. So the one that the model chooses out of these five possible um, continuations to this sentence is playground. Why? Because kwa the training data set that it has been trained on, it has seen a lot of connection between children and playground. Children and playground. Every time children are mentioned, playground is also mentioned nearby. So because of that, it is able to learn that children enjoy going to the playground is the one that has the highest chance of being the next word. So that's just what training does. And and how it works is by, I don't know if I have an LLM here. Okay. So there's the way I have it here. You see the way we looked at this neural network here, this one, we looked at it like this. So, for example, now you've been given the sentence here, the input here, the sentence here is children enjoy going to the, and then in the hidden layers here, it processes that that sentence, and the output here are the ones that we have seen on the other side, that like cafe, like park, like school, and finally playground. So that those are the outputs here. And what happens is once the model is learning, it takes in the large data set, it goes through, and then it goes to the output. It learns that if I wanna predict the word cafe. So, for example, it learns from itself. So it says children enjoy going to there, and then it predicts the word cafe. But then it checks against what is in the data set. The data set says that children enjoy going to the playground, and then it comes back. It alters the way it is calculating things, and then it goes again. It does children enjoy going to there, and it says children are going enjoy going to school, and then it finds out no, still it is not school, it is playground. So it comes back again and then alters its calculations here, and then tries again. Once it gets that children enjoy going to the playground, that model has been successful. So that is a model that you're going to use to 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 do the next step, which is now fine tuning. Once the model has been trained and it is successful, it is predicting the word playground correctly, which is the word that it should predict. It now goes to the next step, which is fine tuning. And this fine tuning step is the step where you've now got this model that can predict the next token, ama the next word. Now you need to be able to have a conversation with it. So you ask it a question and it responds. You ask it another question, it responds. For you to be able to get that, it needs to go through a process called fine tuning. So once you've trained it on that large data set, like the one we've seen here, this one called fine web, once you've trained it on this fine web data set, you come back here and you throw away that data set and you give it a new data set. You tell it that this is the data set I want you to learn from. And what is that data set? It is a data set that contains many conversations that a human and an AI has have had. So, for example, let me show you this website. Let me present this. So I hope you can see this now. So here you see that there's a conversation happening between a user and an assistant. It is what is 2 plus 2? The assistant says 2 plus 2 is 4. The user asks what if it is 2 times 2? The assistant says the answer would still be 4, just like 2 plus 2. And this textual this conversation that is happening here is generated by a human. So mimi kama Alvin, I generate this text information, this conversation, and then I generate a data set. So many of these things like this. So for example, this one is 2 plus 2. Some other one I can ask who is the current president of the United States. The assistant will respond, it is Donald Trump. Then you ask again, how long has he been president? You say he's been president for a few months, like that. So this conversation, you create a whole data set of something like that, and then you train the model. The model that you've already got, you train it on this data set that you've generated of multi-turn conversation between a user and an assistant. I hope that has made sense. So once you fine-tuned the model and it is now able to have conversations with you, you ask it a question and it generates a response. Now you can now deploy it to wherever, and it is now being used by 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 the people who want to ask questions. So that's what they did with ChatGPT, they did with Claude and Gemini. Once they've finished the fine tuning, they can now upload and deploy it to be used by everyone. So that concludes the end of today's session. We were to cover um, this today. I hope I have shared enough. I hope I've taught enough on. So we were to cover our virtual session for today is here. So what to cover what is generative AI? I hope I've been able to explain that. Then there is how do LLMs work? I hope I've been able to explain that. Basic tokenization, that is breaking a word into sub words that are called tokens. That's what it does. And then there's training. I hope I've been able to explain clearly what training is and how that works. The thing that we were to do is to check out how ChatGPT works and how Claude works by asking them questions. But I think we've already done that for ourselves, like going to ChatGPT and you ask it a question, and you get to experience it. Um, I think we've already experienced how ChatGPT works. But now for the APIs themselves, I think we'll get to build stuff with them later on as we continue. Just like we did last semester, we built a few projects using the ChatGPT API, the OpenAI API. I think we'll also do something similar like that this semester so that we get to to experience how to build your own chatbot. So I think now that concludes the end of today's session. I would have really wanted us to like talk and converse, but now naona you guys can't unmute yourselves. So and ni sawa tu. So if you have any question, please send it up kwa chat right now so that I can react and respond to any question that you've had. Is there anything that you would like to learn about AI and machine learning? Do you have any question about what I have shared with us today? Uh, any question? Um, John Mark, there's another platform we can use. We can do a Google Meet. I can send a link and then we join and converse there even right now. But also in the future, I will ensure that this meeting is set up in such a way that you guys can also unmute. So I'll go figure out ni setting gani nilikosea. So if you'd like to converse with me right now on Google Meet, I can send a link right now. Yes, there's a WhatsApp group. Let me even send the link to the WhatsApp group right now. Um, invite group link, copy link. Yeah, here is the link to the WhatsApp group. You can request to be added, and then I will add you. Hi, John Mark. Let me create a Google Meet link just right now. If you have any question, you'll be able to ask me here. So as for this session, I think we've come to an end. Unless there's any other question. No, yeah. For ongoing classes, I will set up the meeting so that we can be able to talk and converse. But as for today, nisamehe hapo. I set up the meeting vibaya, so hopefully next time we'll be able to talk. Another thing, I don't know if you guys are able to come to KCA physically for physical meetings. Personally, I prefer physical meetings because we get to interact better, we get to know each other better, we are able to write code together and just interact. It is much more interactive than mimi ku have a meeting virtually. So I don't know if you guys are able to do that. And if you guys are able to do that, I am willing to have the physical sessions. I had thought about having the physical sessions upper, just like I had shared here. But now I was in school today for like 2 hours and no one showed up. But now, so I'm wondering, is it because people are not willing to attend physical sessions? What is the problem? So if you guys are willing for physical sessions, I am ready and open. And these sessions are much more interactive. They are much more fun. We are able to build things and see them working like right there and then. So yeah, I hope if you guys are interested, mnaweza sema kwa group that you're interested. If not, ni sawa, we can still be doing our virtual sessions. Aya, so in case there is no other comment, question, I think we can stop there for tonight. Yeah, I understand your challenge, yeah, classes, but I don't know. I am open to for physical meetings. I'll be in school on Thursdays. That is sure because I have a class on Thursday. So if any of you is willing to meet me on Thursday, sure we can meet. But I also understand kuna watu wako na classes, so that's totally okay. Someone had said if I can share notes. Yes, I will share. I will share the notes. I will reshare this document. This one in a display hapa, but I also share the PDF that the presentation that I was using today. On Thursdays, my class runs from 11 to midday or 1. So anytime from 11 to jioni na huko 4, you can text me or call me or write kwa group and I'll be around to shule. So anytime on Thursday really. Sawa. I think that's it. You're welcome, you're welcome. Good night, mlale fiti na mkuwe na wonderful weekend. Good night.